Then at last day, we obtain the equation for energy of the capacitor. Neither. Okay, there are three equations. First one half QV. Second one half Q squared over C. Third one half CV squared. Okay, then we can try questions using that equations. Okay, first question. 2000 microfarad capacitor is charged to a potential difference of 10 volt. Calculate the energy stored by the capacitor. They given the capacitance value and voltage. Then what's the suitable equation to find the energy stored in the capacitor? Then we have to use equation with C and V. Half CV squared. Yes, half W equal half CV squared. Then half C mean here 2000 microfarad. Micro mean 10 to the power minus 6 into voltage 10 squared. Then here 2 cancel. 10 to the power 3000 into 10 to the power minus 6 into 10 to the power 2. Then it is equal to 10 to the power minus 1. 0.1 joule. Next question. Calculate the energy stored in the following capacitors. Okay, then we can use the same equation. W equal half CV squared half into 5000 microfarad 10 to the minus 6 into 5 squared. Then half into 5 into 10 to the minus 6 minus 3 into 25. 25 into 5 mean 125. 125 over 2 into 10 to the minus 3. 125 over 2 mean what's the value? 62.5 into 10 to the minus 3. That means 0.625 joule. Okay, next one. Then we can use same equation half 5000 here picofarad. Pico mean 10 to the minus 12. 5 squared. Half into 5 into 10 to the minus 9 into 25. Then 125 over 2 into 10 to the minus 9. Then 125 over 2 mean 0.625, 62.5, 62.5 into 10 to the minus 9. Okay. Then it is 6.25 into 10 to the minus 8 joule. Next one, 200 microfarad capacitor and 230 volt. 200 into 10 to the minus 6, 230 square. Ten to the power minus 4 into 230 squared. 230 squared mean 52,900. Then it is 5.29 joule. Next, which involves more charge 100 microfarad capacitor charged to 200 volt or a 200 microfarad capacitor charged to 100 volt. They ask about the which one has the greater charge when it charged up to given voltage. Then we can use the equation මොකක්ද? C equal Q over V. Then Q
Yes, sir.
equal C into V. For 100 microfarad, අපිට හොයන්න පුළුවන් charge එක Q equal 100 into 10 to the power minus 6, voltage 200. Then it is 2 into 10 to the power minus 2. 10 to the power minus 2 coulomb. Okay, then for 200 microfarad capacitor, Q equal C mean here, got the C 100 volt into 200 into 10 to the minus 6. Then it is equal to 2 into 10 to the power minus 2. Oh, both charges are equal, neither. Yes, both charges are equal. Now they ask about which store more energy. We can use Q squared over C power neither. Then here Q is constant. Q is constant for both capacitors. Then we can decide W proportional to, that means energy proportional to the inverse proportional to the C, which has the greater C, then it has lower W. Greater capacitance means 200 microfarad. Then 200 microfarad has lower energy. Then 100 microfarad has more energy. So 100 microfarad has more energy. Next, 10,000 microfarad capacitor is charged to 12 volt and then connected across the lamp rated at 12 volt, 36 volt. Calculate the energy stored by the capacitor. Okay. Then we can use W equal half CV squared. C mean 10,000 into 10 to the minus 6 and 12 squared here. Then 10 to the power 4 into 10 to the power minus 6. 12 squared means 144 over 2. Then 144 over 2 means what's the value? Yes, 72. 72 into 10 to the power minus 2. Yes. That means 0.72 joule. That is the answer for the part A. Part B, estimate the time the lamp stays fully lit. Then assume that the energy is dissipated in the lamp at the steady rate. Okay. Then this energy in the capacitor, used to light up the lamp. Lamp has 12 volt. Need to supply 12 volt. Then it power 36 volt. Then what's the equation that connect P and voltage? We can use P equal.
Q.
There are three equations. Three equations for the power dissipation through a resistor. अब यार AS level
Yes.
लेके गए P equal Vi and I squared R and V squared over R. Then here we don't know the value of the R. R අපි දන්නේ නැහැනේ. Then we can use P equal Vi නේද? P equal Vi. Then current equal to Q over T. Then instead of I we can substitute Q over T නේද?
Yes.
මේක මෙතන දාන්න පුළුවන්. P equal V Q over T. Then T equal, this is the time taken. T equal VQ over P. Then Q mean here 10,000 microfarad. Voltage equal to 12 volt. Then it is 12 into 10 to the power minus 1. Minus 2, minus 2. This is the value of Q. Then we can substitute. Time equal this equation. Time equal voltage equal to 12 volt. 12 into 10 to the minus 2 over power 36. Then we can cancel. There are 3 12s in 36. Then 12 over 3 mean 4. 4 into 10 to the minus 2 second. Then it is
Yes.
0.04 second. 0.04 second. Next question. In simple photographic flash gun, 0.2 farad capacitor is charged by a 9 volt battery. It is then discharged in a flash of duration 0.01 second. Calculate the charge on the charge and energy stored in the capacitor. Okay. You can use Q equals CV to find the charge. 0.2 farad. Voltage equal to 9. Then 1.8 coulomb. That is a charge. And energy, to find the energy, we can use W equal half Q squared over C. Then half Q squared mean 1.8 squared over C. C mean 0.2 farad. Then it is 16.2. 16.2 joule. That is the energy. In part B, they ask the average power dissipated during the flash. Average power dissipation. We already found the energy, energy
Yes.
stored in the
And the time
capacitor.
they have given us, right?
Yes.
We have to only divide it.
Yes. Power equal W over time taken, 10.2 over 0.01. That is equal to 162 1620. Yes, watt. That is the average power. Next, they ask average current in the flash bulb. Average current. To find the average current, we can use I equal Q over T. Q is equal to 1.8 over time taken 0.01. Then that is 180 ampere. Greater current නේද? ලොකු ampere එකක් flow වෙනවා through the flash light. Next, the approximate resistance of the bulb. Approximate resistance. To find the resistance, we can use P equal I squared R. approximate resistance. Then R equal P over I squared. We already found that P 1620, I squared mean 180 squared. 180 squared. 0.05 ohm.